Hello and welcome everyone. My name is Mark Henry. I'm a senior engineer with opMantek's North American office located out of Charlotte, North Carolina. Today we're going to be talking about how to leverage trending data for thresholding and performance analysis. For all of you live in today's GoToWebinar, we will be following up today's webinar with an email with a link to the recording itself. For those of you that are on YouTube or have found this presentation on opMantek's learning portal, you'll see a copy of the recording there, as well as copies of all of our handouts and downloads. Feel free to submit any questions you have throughout the presentation. We'll be keeping an eye on the questions panel. Happy to answer anything. Rather make this more of a live discussion than just a one-way presentation. And of course, when the presentation's over, if you'll please take a moment and complete the exit survey, would appreciate it greatly. So today we're going to focus in on opMantek's opTrend system. opTrend is a SEDS-based trending calculation system that looks at every individual parameter of every device that's being processed in 1 hour increments on a day of the week basis. So for example, Monday from 9 a.m. to 10 a.m. is different from Sunday afternoon from 3 to 4. And so we look at those 1 hour increments on the days of the week. We create a standard deviation matrix from that, and then we figure out what is normal operation for each parameter of every device that's being processed. So today we're going to talk about that opTrend system in detail. We're going to take a look at how it works, what it does for you. We'll compare and contrast it against NMIS's static thresholding system, and then we're going to talk about how opEvents can be used to really expand upon the information from opTrend and build on it and provide you with a very dynamic way of responding to trend-based events as opposed to threshold-based events. As always, I like to marry these presentations back to Gartner's IT Service Management Maturity Model. So when you start looking at opTrend and the trending information it provides you, solidly it expands on level 1 for initiate problem management process, alert and event management. It also builds out level 2 significantly by analyzing trends, setting thresholds, and predicting problems. It also adds a level of automation to the system. When we actually take a look at opTrend's interface, while it's extremely useful for digging in and understanding what's happening on your devices, one of the great benefits of opTrend is it just works in the background. So as devices are added to NMIS, NMIS adds them to opTrend, opTrend does the calculations and then generates events based on those. So you don't actually have to use the interface, so it automates a lot of the work that you would normally do. There are 2 components to today's solution. The first, of course, is opTrend itself, followed on by NMIS, opMantek's core performance fault monitoring solution. We will touch on opEvents, which is our operational automation tool. It's the manager of managers that handles event management, not only inside processing NMIS, but also processing syslogs, and you can even send events to it synthetically from other applications. For useful references, you of course have the opMantek wiki. So we have the links here for the NMIS portion of the wiki, the opTrend, and the opEvents portions. If you have any questions regarding opTrend, feel free to post them to the community questions board. If you're looking to do a proof of concept, if you want to try out opTrend, you can reach out to sales. So email usa@opmantek.com. If you're not in the North American marketplace, our USA team will be happy to do a referral into our Latin American team or our Pacific locations. So let's talk about opTrend. When it comes to kind of event and fault management, we take a 5-step approach. The first is to manage measurement and thresholding intelligently. The second level is to capture event details from all events, assign priority based on measured impact, then conduct troubleshooting and remediation automatically. So again, we cut down on kind of manpower and repetitive motion there. And then finally, alert the correct resource in a timely manner. That first level, that top one, manage measurement and thresholding intelligently, that's really what we're going to be focusing on today with opTrend and what opTrend can do for you. Because everything about event and fault management starts with measuring the performance of different metrics on a device and then setting alarm levels, or what we call thresholds, in an intelligent fashion. So as I mentioned, NMIS is opMantek's kind of core fault and performance monitoring solution. It's actually reaching out to all your devices. It's pulling them using SNMP and using WMI. It's also processing SNMP traps, so you can push SNMP traps to it. It's also doing application monitoring as well. So you're getting user experience monitoring, application monitoring out of NMIS. NMIS has a built-in thresholding system. So for every single parameter that's being collected by NMIS, there are built-in thresholds that are there predefined based on the model, manufacturer, and even the operating system of a device. So for example, in the little screen capture on the right-hand side, you'll see that the event is called a proactive CPU. We're actually looking at the OID point called average busy 5 minutes. There's a control being applied to this, so any device marked as a core device will have this set of thresholds. So NMIS actually has 6 built-in threshold levels. You have normal, warning, minor, major, critical, and fatal. You'll see these defined in the bottom right-hand side of that screen capture. They are listed in alphabetical order, so you'll notice that critical and fatal are swapped in that listing because they are listed in alphabetical order. NMIS's thresholds can be rising or falling. So for example, you might want to have a threshold for bandwidth utilization. And so you might set off alarms at, let's say, a warning alarm at 60% utilization, minor at 65, major at 70, fatal at 85, or critical at 85 rather, and fatal at 95. You could also do a falling alarm. So you may have an interface that you know should never go below 15%. So for example, you might then use a warning alarm at 18, minor alarm at 16, major alarm at 15%, critical alarm at 10, and fatal alarm at 8%. So you could have a falling alarm as well as a rising alarm on the bandwidth of an interface. So again, those are all predefined based on manufacturer input, recommendations from different manufacturers on their devices, but also from our more than 20 years of engineering experience working with different devices and what's normal and what's acceptable. So how does that compare to using opTrend? The first thing to really understand with opTrend is that opTrend doesn't really care what the vendor suggests is acceptable performance. opTrend looks at what a device is actually doing, or what an individual parameter is actually doing, and then tries to determine what's normal operation for that parameter. So whether opTrend is looking at bandwidth utilization on an interface, whether it's looking at temperature on the device, whether it's looking at CPU or memory utilization, it looks at that parameter, that individual parameter. It breaks that parameter out into what's normal in 1 hour increments on each day of the week. So every day of the week has 24 1 hour increments with it. And opTrend looks at, for example, Monday morning, 9 a.m. to 10 a.m., and it looks at every single Monday morning for the past 26 weeks. And it uses that window, that 1 hour window of information, to build a standard deviation. So for those of you who remember your statistics classes, generally speaking, about 99.7% of all performance falls within 3 standard deviations from the mean, or the measured mean of a parameter. And so what opTrend does is it actually creates that window, that nice sinuous curved line that you see there in the bottom right-hand corner, and determines what 3 standard deviations of normal off the mean would be. And then it determines that if the actual current performance goes outside, above, or below that 6 deviation window, again, 3 standard deviations above and 3 standard deviations below that mean, if the measured parameter goes above it or below it, then it's an alarm. It's an event because it's outside the standard window. So you can actually use opTrend to enhance NMIS's static thresholding, or you could actually replace NMIS's static thresholding entirely. So you could ignore NMIS's alarms and simply go off the alarms from opTrend if you wanted to. So you could use one or the other or a combination of both. What we're going to talk about when we start looking into opEvents and how opEvents handles opTrend's alarms, we're going to talk about how to intelligently determine which alarm you should respond to, and we'll give you a couple examples there. So this is an example of what we call a SEDS alert or a SEDS measurement window, and you'll see here running through the middle of this this chart, there's a green line. That's actually the mean that's being measured across time. And then above that mean and below that mean are 3 standard deviations. So you have the upper control arm and the lower control arm. That's the blue line at the top and the blue line at the bottom. So you have the lower control arm at the bottom, the upper control arm at the top. And that's simply marking out, again, think about that nice bell curve that we looked at a moment ago. That's marking out the left and right corners of that bell curve, 3 standard deviations from the mean. The black line running through the middle of this diagram is actually the parameter being measured. So that's the live parameter itself. And I've just zoomed in for the screen capture. But you can see that that live parameter has exceeded or gone outside that upper control. And so anywhere that measured piece is outside that upper or lower control, that in itself is an event, because that's outside what opTrend considers normal for that 1 hour window of time. So how does opTrend work? So in the center of the screen here, you'll see we're kind of looking at the concept of the different pieces of software on a polling server. And you have NMIS in the center. And again, it's processing SNMP and WMI polled information. It's also receiving SNMP traps, and it's monitoring different types of services. So it might be monitoring applications, websites, user experience at different remote locations, and it's generating events from those. So NMIS takes all that performance data and shares that performance data from NMIS's RRD, or round robin database, to opTrend. All that data, all that performance data is copied over from NMIS and into opTrend's MongoDB. So Mongo is a big data backend. It's designed to be kind of a time-related database that stores large document-based clumps of information. So that performance data is shared with opTrend. opTrend then processes it following the settings within opcommon.nmis and generates trend-based events. So anything, again, that falls above or below those control lines is an event, and those events are passed back to NMIS. So you can use NMIS to gather and process your information, opTrend, again, to determine trend-based events, and then NMIS to handle escalation. However, NMIS can also pass those events on to opEvents, opMantek's manager of managers. Now, opEvents has the ability to handle things like event correlation, event deduplication, event storms, event notifications as well, but it also does remediation. So opEvents can actually see an individual event or group of events, and based on those, take proactive response, whether that's just gathering troubleshooting information or whether that's actually reconfiguring an interface on a router, restarting a service, rebooting a machine if it needs to, or escalating upon different levels based on other parameters that it sees. So opEvents is a very intelligent solution, and you can do a lot of event orchestration through it. Let's go ahead and expand this view into a wider view of opMantek's solution sets at both the polar and a master level. So the concept here being is that you can scale opMantek's network monitoring applications horizontally and vertically. So you can deploy multiple polling servers, whether that's logically within your network or geographically. So if you're spread out geographically across a large number of states, a wide number of geographic location with a lot of latency between those locations, you could put polling servers in different physical locations or simply logically within your own network. And those polling servers can report up to one or more master servers. And so you'll see here, for example, that if NMIS passes events to opEvents, that those events can then follow certain rules and then be passed up to a master view. So in many cases, when we're dealing with larger businesses that are running a NOC, a network operations center, they don't want to see every single event that's happening across the network. They want to see just a subset of events that meet specific criteria for them. And in this case, scaling out using opMantek's solutions makes an awful lot of sense. And again, the concept of opTrend handling trending information, that happens at the polar level. So you're distributing processing. For example, if you had 2,000 devices being monitored and you wanted to do 1,000 devices on each polar, you might have two polars, each polar processing and handling its own devices, doing its own event management, doing its own alerting, and then escalating events that meet specific criteria up to, again, one or more master servers. So how do you implement opTrend? It starts, it's pretty straightforward. It's an installation, goes right on top of NMIS. If you download the opMantek virtual machine, if you'd like to take a look at opTrend, opTrend is not included with opMantek's VM, our virtual machine, which is now based on CentOS 7. But if you contact us, again, USA@opmantek.com or contact@opmantek.com, we'd be happy to get you the download instructions and a 30-day trial license to check out opTrend and understand how it works for you. But our recommendation is you start trending with your core devices. You really pay attention to those core devices, understand the data that opTrend is getting to you. As you kind of get to 45 or 60 days, about 2 months worth of data, then you can enable trending or trending thresholding. And again, you would do that through opcommi.ms. You can actually turn on event creation at that point. The reason we recommend waiting is, again, opTrend is looking at 1 hour increments on a day-by-day basis. So if you only have 2 or 3 weeks of data, you've only got 2 or 3 data points for each day. And so the more data that you capture, the better able opTrend is to understand what's normal operating conditions for that device across a wider set of parameters and usage. At that point, you would then adjust how you respond and what you respond to with opEvents using the eventactions.nms file. We're going to take a look at that. So how to handle opTrend events in opEvents. So as a kind of a quick sample, this is what we call a complex adaptive solution, which is one way of creating event responses in opEvents. You certainly don't have to be this complex right out of the gate. You can be very, very simple and straightforward. We like to use this example because it does get people's gears turning mentally about what the system can do for them and how it can be configured to really be a very, very robust response system. So for example, here we have time 0, some event has occurred. It doesn't matter what the event is. It might have been a device down, an SNMP down. It might have been the loss of an interface, but some event has occurred that started off a timeline, a process of responses by opEvents. And over this timeline, opEvents is going to be evaluating the event, determining what needs to be done, perhaps who needs to be emailed, who needs to be text messaged, what prioritization the problem should have. Also, maybe what action should be taken. So in this example, opEvents is going to ping the device and then do an Nmap port scan. It might also run an MTR and try to capture more information. And if that MTR indicates a change, then it might actually create a whole separate timeline running its own events. Meanwhile, again, the main timeline might evaluate, is this event service related? If it is, maybe it needs the service restarted. If MTR is changed, again, doing more evaluations, collecting additional troubleshooting information. Perhaps if that troubleshooting configuration checks indicate config changes in the device itself, that might start a third timeline. So you can spawn off additional timelines. Each of these can be working independently of each other, or they can be working together. The whole idea is that at some point you're going to be able to come to some resolution. Either the problem's been fixed and corrected by the automation, or human engineers have been involved and they have access to all the troubleshooting information now, and they're able to use that information to make a informed, educated decision on what the the root cause of the issue is. So along those lines, how is that done? All of your events, again, are being passed from NMIS to opEvents. Those events will include all of the regular thresholded events that NMIS is working on. So all of the static thresholds are being applied to all of the different metrics that are being pulled in from SNMP, WMI, SNMP traps, and even service-related polling, user experience-related polling. But NMIS is also processing through opTrend, trend-generated events. So again, those are events which are above or below the upper control or lower control of opTrend, and those events are being processed by NMIS and then being passed over to opEvents. In opEvents, we have a processing file called eventactions.nmis. That file has all of the rules built into it on how to handle events that are being passed into it. So if you're using opTrend, one of the things that you can do is you can actually tell the difference between an event generated by NMIS and an event generated by opTrend. And that's because the opTrend events actually are prepended with a specific keyword. And we'll show you that in a moment. One of the other things that you can do in opEvents that you can't do in NMIS is in opEvents, you can actually determine how many weeks of data you have for the device in question. So if you have enough weeks of data involved, and that's kind of an arbitrary decision, we like to recommend more than 12 weeks. I personally prefer 16 as a starting point before I enable trend-related events to be processed. But again, you can set that how you want in the event policies. And if we take a look at what that looks like, and just zoom into this top policy. So for example, you'll see here, we're looking for an event that includes the phrase opTrend in it. So that's the keyword I mentioned. So opTrend, trended events will have that prepend in the event name. And opTrend weeks is less than or equal to 16. So in this case, we want at least 17 weeks of data. We can add a little processing note tag that'll appear in the opEvents window. So when you actually look at an event, you'll understand why the event wasn't processed. And then we also acknowledge the event. This isn't a hard and fast rule. This is just a recommendation. This is a rule that we wrote actually for a regional ISP that was looking to implement opTrend and who would be adding and removing devices from their network often. And so as a result, they weren't able to simply bulk add all of the devices at once and then get to a specific calendar date and time and then enable events from opTrend. In this example, they had to be able to add events or enable events from opTrend on a device-by-device basis, because while they might spin up and start with 5,000 devices in 6 weeks, 500 of those might have been retired and replaced with new devices over several weeks worth of time as older devices are being retired and managed out. And so different devices, every device would have its own number of weeks of trending data behind it. And so we had to be able to have a way to dynamically respond to that and turn on and turn off events and event handling from that. So what I'm going to do now is I'm actually going to switch over to opTrend. So here I am, I'm on opMantek's demo server. This is the default dashboard for opTrend. You'll see down the left-hand side, we have kind of the top end graphs for the different processes that are being monitored. So for example, we're processing CPU load, memory utilization, TCP, current established connections, and HR system processes. Then under interface trends, we're looking at if-in utilization and if-out utilization. So different ways of breaking this information down by, again, different parameters. I personally like to use the top-end billboards, so views, top-end billboards view. I like this because it allows me to see how different devices are trending against each other. So opTrend is comparing all of these different devices together, keeping track of changes. In this case, it happens to be CPU load, but let's take a look at if-out utilization. And if let's come down here to the B&E switch, and I'm going to click the little eyeball over the right under the view SEDS column, and that's going to give me this chart. So this is going to show me the last week of data on this. So this is 1 week worth. And again, I can zoom into this however I want to. So for example, if I want to break into this, and then let's just zoom into this one piece. So this is giving me a view from 8 p.m., so 2000, through till 8 a.m., so it's about a 12-hour window here. That's what I'm looking at the moment. And again, you can see the upper and lower control arms in blue. You can see the mean line in green that's created that starting point, again, that bell curve. And the upper control is 3 standard deviations above the mean, and the lower control arm is 3 standard deviations below the mean. And then you can see, for example, at this point, that peak has gone above the upper control arm. That would have created an error or an event within NMIS that would have been processed through. Coming over to opEvents. So I'm looking at the opEvents main dashboard now, and I'm just going to scroll down. And for example, you can see here there are several CPU-related events. And you'll see that it's named Proactive opTrend CPU load. So the event is CPU load. opTrend, of course, is what's creating that event. Let's see if we've got one here. We've got one here for an interface as well. So opTrend TCP current established. So you can see that it's exceeded positive control by 3.4. You even have a link directly to the SEDS document that supports that. And in response to this event, opEvents started an escalation. It's running an Nmap scan on the device, gathering services. It's also run an open audit of the device. It did a ping node. And a status was changed on it. So you can also see that it was auto-acknowledged because the state itself changed. So it went above the allowed SEDS measurement and then came back down below it again. And so it actually closed itself. But despite the fact that it was closed, this event has still gathered a tremendous amount of information. So you'll see, for example, the ping node results, the Nmap service scan, service detection was performed. You see the different services that are running here, HTTP, SSL, and SSH. All right, that concludes our overview of opMantek's opTrend trending and performance module. I hope you've all gathered something good out of this presentation today. If you have any questions at all, please feel free to email me directly. You can reach me at markh@opmantek.com. That is my live, real email address. I do respond to everyone's email, so if you have any questions, feel free to reach out. That's also my cell phone number, 207-951-2428. Feel free to give me a call if you have any questions. Please don't be offended if I pass you to voicemail. I'm often in presentations like this or in sales presentations or working with other customers. If you leave me a detailed message, I will get back to you as quickly as I can. Thank you again for your time today. I look forward to seeing you again at a future webinar.